This is just a breakdown of okay, what are the different types of machine learning algorithms out there? And many of you are already familiar with this, and some of you just have never seen this before. So just want to run through it real quick. So you have really three different types. You have supervised, unsupervised, and reinforcement. It's actually a semi-supervised as well in there. And that's actually reinforcement, I guess, would come under that, where it's a combination of those two, supervised and unsupervised. So let's start with supervised learning. Supervised learning is where I have a data set and I have a goal that I want my machine learning to do. I have something I want it to learn. I have a definite set of outputs, I have a definite set of inputs, and I want it to learn that relationship. So basically it iterates through a process to get to that point where it understands how to manipulate your inputs to be an exact output. And there are two types of outputs that we could have it learn. One would be classification, which very simply would be, is it a tree or not? Is it a cat or not? Or taking it further, is it a cat or a dog or a bird? Those are all definitive answers to a question, yes or no. Cat or dog, it's 1 or 0 is your output. Another type of supervised learning is when your output is not something like a class of items, objects. It's a regression, which is a analog output. Analog one, a number between 0 and a million. Let's say like a price. Having it learn what's the optimal price to sell at. Let me think what else. A count of units that I'm going to sell, something like that. It's not is it this or that, it's how many, how much. That would be a regression technique, but you're still setting your output to something and having your process learn it. And there's a subtle difference between the algorithms that you use, but many algorithms apply to both. And then you can see there's different examples of each one of those types of learning. Okay, so another type of learning, so like say you don't have a defined problem to solve, definite output to learn. I just want my network to just classify things, but I don't necessarily know how it's going to come out with an answer. It's just going to divide up my learning data, my input training data into different classifications. It's going to just naturally see how to do that. And we'll talk about this much more. And it's basically that's clustering. It's just like, let's say I have a bunch of customer sales data and what they purchased, and I want my algorithm to just break all the customers up into 4, give it a number, different groups, and then see what happens. And that's it's fascinating what kind of information it'll come up with. It may come up with seasonal versus everyday customers. It'll come up with something. Basically that's the customer segmentation problem. And also there's this dimensionality reduction, which, say we have 10 inputs to our neural network, then that's too many, it's taking too long. And we know that some of those inputs are related to each other. So if one's high, the other one's always high. Like for instance, if we're working at a similar margin, the cost and retail of a sale would be, those would be related to each other. So if we apply this dimensionality reduction to that data set, it'll combine those two inputs, which are dimensions of our data, together, and then we have a simpler model, simpler data set to feed our model, and therefore a simpler model, more accurate, perhaps. So those are some applications of this unsupervised, where we don't really know where we want to go with this data. We just want the network to simplify it, to come up with groupings. And then there's this reinforcement learning, which I'm just like, I'm so into this right now. It's incredible. It's game theory is part of it. Game ions right there. It's basically taking a robot and saying, go learn how to walk, and just reward it when it moves its foot forward. You know, when it starts to do something like walking, then you have an automatic reward system that's giving it. So it just tries different things and just throws away the things that didn't get a reward and keeps things that do have a reward. You know, it's incredible. This is, I think, going to end up being, you know, the be all and end all of AI, because it can encompass all the other areas. You know, you can apply neural networks to this, so it can learn very, very, very complex things. So it's incredible. It's anyway, can't say too much about it.